Welcome back, Pre-Calculus for Relaxed section within 1 or 5.1, and that's going to be dealing with velocity. Don't forget, velocity's general description, something we need to remember, is going to be the distance divided by time. Any type of velocity can get broken down into something like that, distance divided by time. So when we're looking at the angular velocity of an object, it's going to be defined by the number of rotations per unit of time. Typically what we use is a symbol omega to represent this. So what I mean is, imagine an angular velocity would be like if here's you and you're really bored and you hold an arrow, the number of times that arrow makes a circle divided by some unit of time would be your angular velocity. It's not talking about the distance you travel. It's almost talking about like if you had a top and you were to spin that thing, the number of spins it would make given a unit of time, that's its angular velocity. The formula for angular velocity is going to be omega equals, in this case, the distance we keep coming back to isn't going to be an actual distance. It's going to be the number of revolutions, or the angle divided by the time. In this case, the angle would be measured in unit, maybe in radians, maybe in degrees. Most likely in radians is what it's going to be. The linear velocity is going to be a little bit different. It's defined by the change in position or the distance traveled per unit of time. So let's say the difference is, instead of this time, here's you, here's your little arrow. Rather than you rotating in a circle, rather than spinning like a top, what you're going to do is you're going to create a little circle for yourself, and you're going to run along that circle. So rather than staying right at the center and kind of spinning, you're now running around that circle. The distance that you cover around that circle divided by the time is going to be your linear velocity. You can think of it as if you weren't to be running in a circle, but you were to lay that in a straight line, it would be the time it would take for you to cover that distance over a line. The formula for linear velocity is still distance divided by time. So we got to think about that. Distance divided by time. Well, we have a formula which says if we know what this angle theta is, the arc length is equal to the radius times your number of rotation. That's your distance divided by time. Well, if you group these a little bit differently, that's going to be the same thing as r times theta over t, which equals r times omega, or radius times omega. All three of those are acceptable ways of thinking about this. But the big thing is it's your distance. You can figure out the distance by figuring out the arc length, or you can think of it as the radius times your linear or your angular velocity. Looking at a simple question, a wheel has a radius of 15 inches. What is its speed in miles per hour? So what is its in talking about miles per hour is looking for its linear velocity if it takes 150 rotations in 5 seconds. Well, let's think about this. We can say the linear velocity will equal r times omega, and I think this one's easy to go with because they're telling us our omega. So the linear, we're going to look at r times omega. The reason why is we can figure out omega pretty easily. We're going to say omega is 150 rotations per every 5 seconds. That means it's 30 rotations per second. In order, though, to figure out the linear speed, we need to be looking at radians. Well, 30 rotations, if we figure out how many radians that is, we just need to multiply by 2 pi, which equals 60 pi radians per second. So our linear velocity will equal 15 inches times 60 pi per second, 60 pi per second revolutions. But here's the problem. We're looking for miles per hour. If that were basic, we'd be done. But it's a little bit more advanced. We kind of got to take a look at some unit analysis. What I'm going to start multiplying by are equivalent expressions to get us from our warm current units, which is inches per second, down to miles per hour. So let's handle the inches first. we know that for every 1 foot, there are 12 inches. Notice when I multiply these, the units cancel. Times 1 mile has 5,280 feet. Times. Now let's get rid of these seconds. We know that there are 60 seconds in every 1 minute, and we know that there are 60 minutes in every hour. In this case, we can see literally our units cancel. Inches are gone with inches. Feet are gone with feet. Seconds are gone with seconds. Minutes are gone with minutes. And what we're left with is miles per hour. When we multiply all those numbers out, we end up getting 160.65 miles per hour.